final semifinalist presentations. Bill, all yours.
Thank you very much, Carol Ann. What a pleasure to be here and an honor to be selected as a semifinalist. Phil Mango's here, my colleague James Ferraro right next to me, sliding in for his part. We're here to talk to you about our STAT LLM toolkit for ISD, coming at you live from sunny Tampa Bay, Florida at our headquarters here. And really our purpose today is to tell you or to show you that just like motor oil and diamonds and that nice AstroTurf on the golf course and virtual reality, that synthetic is better. And I'll explain how in just a moment. Just by way of introductions, we are a Central Florida-based firm that is focused heavily not only on the simulation and game-based assessment for training and adaptive technologies for training, but also in the field of personnel selection and assessment and recruiting, and using algorithmic and artificial intelligence and machine learning approaches to predict human performance in a variety of very tough jobs, both in civilian and military space. Really, I think one of the benefits of doing all of that is that we've been developing the blueprints for those training and selection solutions in the field of job analysis, task analysis, training requirements analysis for many years. So that really gives us the mental model to that conforms to how ISD analysts work and think when they're performing their ratings. Our RRL challenge team is myself and Jim Ferraro and Hyder Saeed, who's our DH. So our interpretation of the problem statement is very straightforward. This process of doing ISD ratings is simply very difficult and very time-consuming to be done correctly. In an ideal world, it requires interviewing hopefully multiple SMEs when you're reporting on a single Navy rating and duties, and repeating that process every time. So there's a requirement to look at things like inter-rater agreement and make sure that people are correctly capturing all the different perspectives that people have on their jobs. This is very manual and time-consuming if you're going to do it right. So our solution to that, using artificial intelligence, large language models, and some other techniques, is to really use a lot of available data that's already in existence out there to really help streamline that process. And that analogy with the synthetic motor oil and the diamonds and everything, it's kind of analogous to when you're trying to, when you have a high demand for a very rare material, and your choice is to either go and mine it everywhere, kind of like what we're doing now with the SMEs, going to individual operational SMEs and getting ratings from them. Or if you have a very large quantity of a similar material and a known chemical structure of that you can extrapolate to create the new material, that would greatly cut down your development time and greatly impact the quantity of that new material that you need. So we are sitting on a gold mine of occupational data with the Occupational Information Network, also known as the ONET, and the NAPCR's occupational standards. These are available ready for download immediately off public websites. Our technical approach synthesizes the ISD rating values from these open source materials. And when we say synthesizes, it's using a set of algorithms and the inherent artificial intelligence from these large language models and sensing the relationships between the civilian occupations and the military occupations which we're trying to get ratings for. And using all that contextual data in a very smart way to produce a preliminary set of ratings that the ISD analysts and the operational SMEs would then verify and confirm in their interviews, greatly reducing the time from many weeks to a couple of hours to produce the preliminary data. Operationally, this was done in the challenge using our own fine-tuned custom iteration of a public large language model, using two of the best performance large language models out there, GPT-4 and Gemini. We developed some smart prompt level micro learning for the models that alleviates the need for an ISD analyst to do any intensive coding. They can simply teach the model as they proceed through the prompts with some micro learning, which we'll show you live. That's the synthesis step of our technical approach. The optimization step is something that we did not do because that would require proprietary data from the Navy. But that is a step of our approach that we're proposing for the future. That involves optimizing the initial estimates that were synthesized in the earlier stage. And then the final stage is actually executing the ratings using a comprehensive prompt engineering library that we developed. It allows the rater to take different personas, just like you would in a real world job or task analysis, from the role of incumbent or supervisor, independently estimate things like inter-rater agreement to look at the quality of the ratings, and also include some specific prompts to get the model to reflect on itself and provide independent levels of its own confidence in the response. So to help you visualize all that in a very easy way, this is basically the current approach where we have ISD analysts and operational SMEs working side by side and independently rating each of many different rating scales in the task analysis, learning analysis, and the selection phase. And those feed into the final training product development. Our approach models basically retains a lot of those connections, but adds this central component here, our STAT ISD toolkit, which accesses the ONET and the NAPR's occupational standards, makes sense of them, synthesizes the ratings for each of the three primary phases of ISD, puts those ratings into that same Excel format as the aids that the ISD analysts use now, and allows the analyst and the SMEs to confirm those ratings. That optional machine learning prediction model that we have up here in the upper right is something that would even boost the quality of the ratings even further using closed loop data from both the ONET and the occupational standards. So the large learning models that we had tested for our approach, we simply took the best ones in existence now and did our own customization of those to essentially teach them about the nuanced aspects of the construction electrician job or Navy rating that was used for the challenge. Those two sets of models were the GPT from OpenAI. We developed or looked at 3 different versions of that, and the newly released Google DeepMind Gemini Pro model. For GPT, we did develop our own fine-tuned model trained on thousands of lines of data from the ONET and the occupational standards, and then 2 standalone versions of GPT-4 that were released, basically the newest and best ones that are available now, without doing any fine-tuning on those, so that we can compare and contrast the results. Start off with Gemini, which, even though it's been open to the public for a very short time, really provided some very high quality responses. In-depth, comprehensive, complete, logical, or some of the adjectives that we use to describe that. When we check the outputs of that model against our instructions for the rating scales, we had 100% adherence to the rating scale format. It was able to give us a 1 to 5 scale, a 1 to 7 scale, depending on the individual ISD scale that was being used. When we checked the accuracy of that model against known ratings, which, for example, for the analogous electrician civilian job in the ONET, we actually have a set of task importance ratings for a very similar set of tasks as those that were released for the challenge. And we were able to see very high accuracy for those ratings. For the trust element, it had a consistent and coherent rationale for all responses. And it's the standard output of the Gemini model is to offer 3 different versions of each response, which is idiomatic to us actually analyzing the differences in the ratings and producing an iterative agreement interval. Only downside to that is that it's so new that it's not yet available for fine tuning. Quick snapshot of some of the output from that. This is during the learning analysis phase when it's translating the tasks into learning objectives. And sensing the rules for combining the difficulty, criticality, and frequency ratings into a set of specific and overall training recommendations, and did a very good job of actually explicitly stating what those roll-up rules were, even though they were not previously defined to the model. OpenAI, also a very promising set of models here. I'm going to hand it over to Jim here to talk a little bit about our fine-tuning process for our customer.
Thanks, Phil. I'll slide in here. Yeah, so one of the advantages that OpenAI provided was that we were actually able to take one of their base models and fine-tune it using the relevant data for our purposes. So I have the steps outlined for the fine-tuning in broad strokes here. I started by selecting the data we wanted to use and identifying these primary sources of data. And then we wanted to construct our prompts for training the model and format them ultimately to comply with Chat Completion's API, the OpenAI format. We were frequently error testing, and ultimately these resulted in a series of JSON files that were used for training and testing of the base model. We split those files into training and testing files, so there were 2 each. About 80% of the data was used for training and about 20% for testing and validation. From there, we went on and trained the model with multiple rounds of training. And then finally, we were able to test the fine-tuned model using some manual inputs and actually, as Phil mentioned, compare them to what would be the data provided on the ONET, for example. So identifying those primary sources, Phil mentioned already the Department of Labor's Occupational Information Network, or the ONET. This is a large database with task analysis data on hundreds of civilian jobs. Some of the key data points that we extracted there were actual quantified importance, relevance, and frequency data related to the tasks performed between jobs, the KSAs relevant to the job, the context and other work activities, the Navy occupational standards, which states the minimum requirements for occupational capabilities in different Navy ratings. We were able to extract key data points from there, including whether or not tasks were considered core or non-core tasks, the pay grade expected to perform those tasks, and so on. And finally, we were actually able to train it on the ISD ratings that were provided as sort of a glossary for training this model, teaching it operational definitions for the constructs of interest for the task analysis model, such as criticality of performance. What do we mean by that? So here I have a roadmap generally for our fine-tuning process. It started with the base model, the GPT 3.5 Turbo, and then we were able to go through 5 iterations of training for this challenge. You can see the blocks in green here were completed as part of the challenge, and the gray are part of the scheduling. It was kind of a scheduling issue, time restraints. We got as much done as we could all the way up until that final presented model. But we do have the roadmap and the pipeline laid out to get to that final learning language model.
So to summarize the performance of the GPT models, just quickly, they both work very good, both the custom version, fine-tuned version, and the open source version that we used. A slight edge with the open source version, although really the limit there was that there's a big difference between 3.5 and 4, so we would expect to see even better results through this fine-tuning on version 4.0. Which we would hope to do if given the opportunity. For our prompt engineering, we really developed a comprehensive library of prompts that allowed us to do some micro learning, basically teaching the models how to work without having to do any intensive coding for the end user. And we'll be showing that in just a minute here. But basically, just to summarize our products for this challenge, we've developed a comprehensive ISD analyst assistant for GPT, which can be accessed and which can replicate the entire ISD task learning and media cycle in about 2 to 3 hours, producing a majority of the ratings and identifying those that would need further input from an analyst. We developed a custom fine-tuned model and tested a couple of other ones. And then we have some training-ready Python data sets that would allow the Navy to replicate our results and simply run that data to create an additional fine-tuned model. And then we have a comprehensive prompt library that would allow independent analysts to basically do the entire process soup to nuts. It's a quick snapshot of what the playground looks like, and we can actually jump directly into that. So this assistant allows you to upload individual files and query it for information from those files to retrieve specific details about different tasks or relationships between the construction electrician and the most similar job that was identified. Here we're talking about, we gave it some instructions that are related to translating the tasks to the enabling of the terminal learning objectives. It reproduces those in a common delimited file that can be simply copied and pasted into the Excel sheets for the formal aids for the ISD analysis. And this whole process follows our complete set of engineered prompts, starting off with querying some initial information about the related job that was identified from the application information network, narrowing that information down, and then ultimately producing the predicted ratings, numerical ratings for each element of the ISD analysis. And then just to look at our fine-tuned model, this is accessible in the assistant to basically do any of the analyses with the prompts using the fine-tuned model. Here it's looking at synthesizing the task learning difficulty rating and doing that for both of the sets of tasks that were released for the second and third round of tasks that were released for the challenge. And then finally, a look at Gemini here, live in action. This is looking at the probability of inadequate performance rating and using the prompt that we developed just specifically for that. So really the point here is that the user use case story is such that really any person can replicate this entire process by accessing just a freestanding PC or laptop with internet access, and access to the internet, to the actual API for our models, and using our set of engineered prompts.
And with that, gentlemen, your time is up. So thank you so much.
Very much.
Can we stop this recording?